Hey everyone, welcome back to the channel. Myself Divyansh Kisarwani, and let's solve the problem Movie Festival 2. I have already solved the Movie Festival 1. You can watch that video because that is required to solve this problem. So let's see what's the difference between them. So in this case, we are given with N movies and K members. We know the starting and ending time of a movie, and we need to maximize the total number of movies that can be watched by these K club members. So there is movies and there is a club member, movie club member, in which there are people. So K can be anything, and we know the starting and ending time of a movie, which in case is this example. 5 is the number of movies and 2 are the people in a club, and they can go and watch the movies, and they have to maximize the number of watches. That means one person can go watch one movie, the other person can watch the second movie in such a manner such that these two members in this case maximize the total watch time. So the same thing in the previous one, we'll watch that movie which is ending first. You know the reason, because you have solved the problem Movie Festival 1 first part. So we are going to watch that movie which is going to ending first, so that in future we have more chances to watch more number of movies. So that means we are going to solve the movies with the ending time same, and we know that the starting time of a movie is greater or equal to the previous ending time, then we can watch. So in this case, we have 5 2, and these are the movies. We sort them based on their ending time. So do note that this is the ending time of a movie and this is the start time of the movie. So in this case, the example, we have two members, and so how they can watch. Let's say the first member go and watches the first member go watches this movie which I marked with a red pen. Then the second member can watch this movie, right? Because it's the next available one. So this would be going to watch the second movie. Now comes the third movie. Can any of the member can watch the movie or not? This guy will finish at 5. This guy will also finish at 5. And the third movie, his starting time is at 3. So he can't go and sit the last hour of a movie, right? He has to watch the full movie. So this can't be watched. So we'll remove this. What about this movie 9 comma 6? It start at 6, and in our list this guy is also finished, this guy is also finished. So we can pick any of them, but if let's say one was finishing at this and another was finishing at, let's say, 6, we'll pick this one. Okay, we'll see this later. So this guy will watch this movie, and now comes this movie. So this movie can be, this movie starts at 8 and this guy is finishing at 9. So our red member is finishing at 9 and our blue member is finishing at 5, right? So he can he this member one can watch this movie? No. Can this watch? Yes. So did you got some hint from here, from this seeing this picture only? I neglected the first one because it was this guy was ending at a very later stage, but this guy was ending fast, so we took this one. So from this we can conclude that the even the availability of members even the availability of members has to be sorted, right? Okay, let's move forward then. We have again the same picture with us, and this is some container which I have drawn, which consists of two people in this case, and I'm not sure which the container it is. We'll figure out that later. Let's try to devise an approach. The first thing, we are going to find the latest available member who can start a movie at or before its start time. The latest available. Do note from the previous example, this boy was ending at 9, this was ending at 5. So we pick one. So we are going to find the latest available member. This is the latest available member. That means we need to do the sorting. Then comes, this is the question which I am going to ask. Just pause it, think it for a minute. Which member can see the movie? Which member can see the movie? Just think about it. If there are a set of members given, think a big example. If a set of members are given, which member can see the movie? The first is who are free, right? Who are free? That means the available time of that member is less than the start time of a movie. So if moving is starting at 6 and the available member is at, let's say, he is free, he has watched a movie which ended at 5, so he's available, so he can watch. So, and this availability time will be nothing but the time of the moving ending time, right? So in this case, let's say if the available time was in 5, because the previous movie he watched, let's say, ended at 5, so the next movie he can watch if the availability time is the movie start time, right? You are free, that means an end movie has been watched, and you can start time of a movie is bigger, that means you can start, right? So let's just try and run maybe this example, so that it gives us a more clarity what exactly we are dealing with. So let's start with the first thing. This is some container. I don't know what the container is. So we'll say that okay, both the members are free. That means free means I will write just free here. We'll pick the first movie, and I am going to ask, this movie is the end time, this is the start time. Always remember why we are doing in this case. Watch the first part basically. So now my question is, find a member whose available time is less than equal to 1, right? Because this is the start time of a movie, and now all are free. All are free. I don't care. You pick anyone. So I pick this red guy and I assign. Okay. And now the availability time of this guy will be is the movie end time. So this availability time will be 5. Great. You understood from here. The first part is clear. Now we'll pick the oh sorry, let's again do this. So this is going to be the ending time, right? So this is 5. Now we'll pick the next one, which is 5 comma 2. This guy. We'll ask again, find a member whose availability time is less than equal to 2, right? Because this moving is starting at 2, I need to find a member who's availability time. So I see this guy is free, I can assign him. We'll give the availability time is equal to the movie ending time. Movie ending time is 5. Great. So this is end, this is start. Now we'll pick 6 comma 3. Again I'm going to ask a question. Find the member whose availability time is less than this start time of a movie, the movie start time, which is 3. Find which is less than means any member who is before 3, like who is finishing at 2 1 3. Is it no? Is it no? So we can't, so we are going to skip this guy. Again the same question, you can think about this. Find a member whose availability time is less than equal to 6, the start time of a movie. Okay, find a member. This guy is also free, this guy, just pick any of them. So now this guy will be 6, and now this will be 9, right? Because now he is going to finish at 9. Done. Next come the second. Again the same question. Find the a member whose available time is before is at or before 8, the movie's next movie start time. So which guy? This guy is done. So is done at 5, because right. So we'll again remove this and assign 10 to it. Now he's going to finish at 10. So in this case we are moving forward like this. So what conclusion we can derive from here? Some conclusion we can definitely arrive from here. The first recap would be, we are going to sort the movie. That is sorting of the movie based on ending time is done. The second conclusion we have already derived. The second conclusion we have already derived from our previous slides, that we have to sort the container also. The container has to be sorted. Because you know why. Let's not again explain that. And the third question I have to ask, I have to again always I have to ask a random a question basically, which is below you. Find a member whose availability time is. Find a member. So in this sorted container, so sorted means this would be monotonically increasing. I have to always ask some question, that find a member whose availability time is this less than this, or this. Find a member whose availability time is this. So can you conclude something from here, that something we have to use to get it? So in this sorted, I have to always ask, find from this uh, find this from this sorted container, find this, something like. So if not, I can give you, it's a bound. We always have to run this upper bound. So container priority, because there is no random, we have to do a random access always from the sorted container. So vector, no, we have to do the sorting and again have to apply the binary search for that sorting thing. Now set can be the thing, right? But we can have multiple values, which was in the previous case. So we can use a multi-set. And the time complexity of the whole operation, log of k will be the finding operation, the binary search only log k, and we have to apply through run it to the whole array. That means o and log k would be our the time complex. Let's see upper bound quickly. What is it? It gives the first element which in the sorting that is strictly greater than a given value. So in this case 0 5 10, and I say the movie start time is 6. So give me available dot upper bound available members list. This is available member list am, I can call dot run the upper bound and give me a value available that is strictly greater than a given value. So that is 6. Give me upper bound of 6, a value which is greater than 6. This would be 10, right? In case of our understanding, let's say the first, there are 3 members in this case, right? Because we have available member as 3 length 0 5 10. So I am asking now the next movie start at 6. Give me a person who is going to be, give me a person who is going to be available from this sorted order, who is going to be available before 6, means after 6, right? So 0, no, it is not. 5, no. 10, we have get the input for the number of movies and the members. Then I defined a vector pair of their same thing, inserted the values, sorted the movies, then I have a multi-set, and then I have inserted zeros just to mimic the free time which I was mentioning, and then I have called a function theater to calculate the maximum number of movies you can watch. So here we have, now we'll get the start time of a movie by saying that movie dot start is present in second, right? And the end time of a movie we can calculate movie dot first. Now we are going to again find the earliest member who can watch the movie. So you can do auto iterator available member dot upper bound, run the upper bound over here, and now what we have to put, just think through this, that the uh, uh so in this case what I'm saying is run an upper bound and say that find the earliest member. So in this case, let's 9 comma 6 only we pick. We say that give me from the available members dot upper bound the start time of a movie, right? Because we need to find the member who's available for the start time of a movie. So dot upper bound of 6, my bad, it has to be 6. Then what this upper bound is going to give, it is going to give, upper bound gives the, as explained, it is going to give the value which is strictly greater than 6. So we have stored the ending time of here of the movies. That means which value is greater than 6. This member is free, we know that, but through the code perspective, how I'm going to say, upper bound will say no, I can't find a value which is greater than 6. And you must be confusing, we need less, right? Devanshu, we need less. You're saying 6, so we need a guy which is 5 4 3, but it doesn't work the case in the code of like this. Upper bound gives the value which is greater than 6. So in this case it can't find, so it is going to give the length of the multi-set which is 3. So 3 is 0 1 in so 3 is basically over here. If just ignore the indexes, actually this might be confusing. So 3 is pointing here, let's say. So upper bound is going to give, the iterator is going to point over here, but we know we can assign a value, so that means what we have to bring, we have to decrease our iterator has to point over here and punch the value over here, erase the value and punch the value, insert the value basically. That means what I'm going to say, first of all I'm going to ask the start time, basically I'm going to punch it, and then I'm going to say decrease the iterator in the available members dot erase that value and insert the ending time of a movie. This guy is going to free at the end time of a movie and increase the maximum movies done. But what if case when the iterator is pointing at the first value, means at the first, then that means we can't do the iterator minus minus because it will go out of bounds. So I can happily say like this, right? In terms of code, this is how we are going to uh, the logic is going to fit in our terms of the code which we have written. So the logic and code has to fit. So that's why we did this kind of check, right? The same thing is there, just a little negotiation we have done. You can run an example to just go over this, but through code perspective, this is how we are going to manage. And in the beginning, when everything is zero, so in the first case, when everything is available members are zero, and we encounter our first movie, which was the ending time. This is the end time, this is the start time. I ask my upper bound. Basically, when we were showing in the code, we were inserting from here, but this time we will be inserting from the back. So the upper bound of 1 is going to give us 1. So upper bound of 1, basically I'm asking upper bound of 1, what it is will be. Give me a value which is greater than 1. I can't find it, so it is going to point the iterator over here. That means I'm going to bring the iterator over here. Is the value, and insert the ending time of a movie, which is 5. Great. Again, our next will be, this will be done. Next will be our what will be 5 comma 2. Okay, I will ask again upper bound of 2. Give me a value, which is greater than 2. But we know we want which guy is free, basically which guy is ending time is before. So 2, uh, we are going to get 5, right? Because this is value is greater than 5. Again, I am going to say bring down the iterator. So iterator will be brought over here, not here. So again, we are going to punch the value. We will remove it and we'll punch it 5. Next comes the value 6 comma 3. So in terms of 3, the upper bound is going to give the first value, right? This value will be given. So we know that this guy is going to give us, but we know iterator is not equal to available.begin. It is equal to available.begin. Hence we are going to skip this. We are not going to punch or do anything. 9 comma 6 comes. Again, give me a value which is greater than 6. Greater than 6, upper bound will say I can't find any value. It will return over the iterator over here. We will decrease it. Punch a value 9 over here. Next comes 10 comma 8. I will ask upper bound, give me a value which is greater than 8. So it gives this value, right? 9 is greater than 8. We will bring down the iterator over here. We will punch the value 10 over here, and we will end movie festival 2. Okay, it has been accepted.